So we talked about primitive values, what happens to non-primitive values. And just to be on the same page, if primitive values are string, number, boolean, undefined, null, begin, and symbol, non-primitive values are everything else, object. So what happens when we are assigning a non-primitive value to a variable, when we change a variable that is pointing to a non-primitive value? So what JavaScript does, it creates a new variable and it points to an object. Okay, in this case, there's nothing in the object yet. We didn't assign any values, and we will see that object, even though it's a value, it acts like a container of variables. Okay, so this is what objects are in JavaScript. So on the next line, we're declaring a property of the object, and the key is name, and the value is a string with Sarah as value inside of it. Object 1 has a property which is the same as variable. You see, name, it's not a variable of its own, but it's a property of the object, number 1 in this case. I just gave it a number just to be easier to explain what's going on. So we're saying the property name of the number 1 object is a variable, and it's pointing to a place in the memory that holds a string with the value Sarah. And the same thing will happen with age, okay? So I'm creating a new property age. Age is pointing to number 30, which is a value in the values word. So what happens with object is some kind of sophisticated variables container. Age pointing to an object, and this object is pointing to two variables or two properties that themselves are pointing to values in the values word. Now, what happens on line 5 when I'm taking B and I'm assigning the value A to B? Instead of creating a copy, instead of JavaScript copying this object, creating a new object in the values world, creating new properties and new values for those properties, JavaScript is just making B to point to the same object in the memory. So instead of copying the object, instead of copying non-primitive value, JavaScript is creating a reference to the same object in the memory. So both A and B are pointing to the same place in the memory. So what will happen if I will change A.age? So let's go through the lines. I'm saying A, it's pointing to object 1, and 1 has age, and age is pointing to 30. Now age behaves just like a variable, and 30 is a primitive value, right? So if it's a primitive value, if I'm changing it, it creates a new place in the memory, and now age is pointing to this new place in the memory with value 35, and its type of number, of course. Now, what will happen if I will do b.age equals 30? Let's take a look at this diagram again. B is pointing to object number 1. Object number 1 is pointing to age, and age is pointing to 35. So if JavaScript will execute b.age equals 30, it will do the same thing like before, even though we used b and not a to reference or to access this variable. So JavaScript will create a new value in the values world, and now age will point to this place. So when I'm using b to change the age property of the object, to also change the object that the age is pointing to, because it is the same object. Because it didn't create a copy before when I created b, but it's pointing to the same object, changing b or changing age through b will change the same object or the same value. Now, if I will execute this line of code, I'm saying const c equals a.name. Now, what I need to keep in mind of, what is the value of name? And if I will go through the line, so a points to object 1 points to name, and name points to Sarah. Now, the question I should ask myself, what is the value of name? And whether this value is primitive or non-primitive, whether it's an object or not. And in this case, name is pointing to a string, and in JavaScript, string is a primitive value. So if it's a primitive value, it will create a copy. So let's see what happens. A new copy of the value that name was pointed to is created in the memory, and C is pointing to this new place in the memory. It creates a copy. Even though name is a property inside an object, the value of name is a primitive value. So when I'm assigning the value of name to C, it creates a new copy in the memory instead of referencing to the same place. Now, what will happen if I will change the value of name. Again, name is just a value as a primitive value. And I'm assigning a new primitive value to name. So if I'm assigning a new primitive value to name, it will create a new place in the memory and will reference name to this new place. Now, one thing to keep in mind is that I'm using const in this code. In the previous code, I used let. What is the difference? The difference between const and let, that I cannot change the reference pointer of this variable. If I'm using const, the only thing I cannot change is the error here, the reference. I cannot play with the error here. I cannot create a new one and assign a new error to A. But even though I used const before A, the const is not applying to properties inside the object. So the object itself is not constant. The variable A is, the properties inside the objects are not constant. So let's just wrap things up. So when a variable with a non-primitive value is assigned to another value, the new variable is referencing to the same non-primitive value in the memory. Again, comparing to primitive values where it creates a copy. So mutating or changing the non-primitive value affects both variables because they're only references. And we saw it in the example before with I used B to change a property inside A, and it changed the same object, right? It changed a property inside object number 1. So both A and B are pointing to the same object, and it changed them both. Or it changed the same thing because they're pointing to the same place.